like to go ahead and review factoring. We've talked about a number of different ways in not only this course but in previous courses. So I'm going to review factoring trinomials, and we talked in class about AC box or split the middle. And so you can use either of those methods. I'll try to do both of them, and both methods require a lot of the same type of information. So for AC box or split the middle, you're going to find what A times C is. And so here's our A value, B value, C value. And so in this case, I have 6 times negative 2. And 6 times negative 2 is equal to negative 12. Then our B value is negative 11. So now we're going to look for two factors of negative 12 that add up to negative 11. So a negative 12 and a positive 1. Okay, and then regardless of your method, either split the middle or AC box, you're going to go ahead and set up the process. So for AC box, we're going to put our A here, our C here. For split the middle, you're going to put your A and your C. Okay, and then we split the middle into negative 12x and 1x. And here it would be negative 12x plus 1x. Okay, so it doesn't matter which way. One way is expressing in box form, and the other way is a horizontal form. Okay, and then we're going to go ahead and take the GCF out of this box, which would be x. GCF here, which would be negative 2. GCF here, which would be 6x, and then GCF here, which would be 1. Okay, so it should get the same answer regardless of the method. We can pull out a 6x here. We're left with x minus 2. And then you can double check. 6 times x is 6x squared. 6x times negative 2 is negative 12x. Same idea here. 6x times x is 6x squared. 6x times negative 2, x times 1, and then there. Okay, GCF from this, bring down your sign. Only GCF they have is 1, and so then we're left with x minus 2. Then you're looking for the common factor. So we have this x minus 2, and we're going to group together what's outside the parentheses. Okay, either way, we're still getting the same answer. So this in factored form is 6x plus 1 times x minus 2. And again, you can use either of the methods, or you can use guess and check. Just make sure you're really guessing and checking. Okay, the next method I'd like to review is factoring by grouping, and factoring by grouping is specifically used for 4-term polynomials, or 4-term polynomials that we've created, as in the case of a trinomial where your A value is greater than 1. So you ask yourself the usual questions when factoring. Is there a GCF? If there's no GCF, then is it a binomial? If it's a binomial, we have the option of difference of perfect squares, and now this year we've added sum of cubes, difference of cubes. If it's not a binomial, then the next question is it a trinomial? And then if it's a trinomial, we can use AC box or split the middle, or you can use guess and check. If it's not a trinomial, then is it a 4-term polynomial? If it's a 4-term polynomial and there's no GCF, then we'll go ahead and start by splitting down the middle. And then we go ahead and we factor the GCF from this section. So in that case, we have an x squared in common, and we're left with x minus 2. And you can always double check with your method. X squared times x is x cubed. X squared times 2 is negative 2x squared. GCF for this section, we're going to bring down the sign. And then I have x, and then minus 2. So negative 9 times x is negative 9x. Negative 9 times negative 2 is positive 18. Common factor comes out, so we're going to group together what's outside the parentheses, and we're left with x minus 2. Now we're not done, because our job is always to factor completely, and we can recognize this as the difference of perfect squares. So we're going to further factor that to x plus 3, x minus 3, and then x minus 2. And then again, we can of course verify that this is the same as this. We can do that graphically to make sure that these two expressions are onto graphically. or you can always verify that these are zeros by trying the factor theorem, remainder theorem from the front side. Okay, I'm going to ask you to do example 4, letter B on your own, and we're going to do our last example today together, which is example 4, which is practicing the sum and difference of perfect cubes. Now, on your last assessment, you had a question similar to this, except I said you could use patterns or you could use the formula. Sometimes it's a little more difficult to use the patterns because we don't know what it's divisible by. So it's easier when you have a division problem, so you know the first factor. In this particular case, we don't have what it's evenly divisible by, so we're going to have to go through a little bit of a different process. I'm going to take a look at my 8y cubed minus 27. I'm going to start by asking myself the usual questions. Is there a GCF? If there's no GCF, is it a binomial? If it's a binomial, is it the difference of perfect squares? No. Then is it the sum or difference of perfect cubes? And in this particular case, it's the difference of perfect cubes, because this is a perfect cube and this is a perfect cube. Okay. A lot of times with these problems, I will just try to identify what my A value is, since I have this formula, A cubed minus B cubed. So if I can identify A and B, then all I have to do is kind of sub into my formula. So if 8y cubed is A cubed, then that means 2y is A. So how do I do that? I take the cubed root of 8y cubed. Cubed root of 8 is 2. Cubed root of y cubed is y. Then I want to identify my B value, and I'll do that by the same sort of process. So I have my 27. Cubed root of 27 is 3. Okay, and then I'm going to go ahead and sub into the formula. So my A value is 2y. My B value is 3. Then I have A squared plus A times B plus B squared. Okay, and then I'll neaten that up and get rid of my extra sets of parentheses. I have 2y minus 3. 2y squared is 4y squared plus 6y plus 9. And again, we can go ahead and check that graphically and verify that this graph is the same as that graph. We can also verify that this equals this when we sub in some value for y. So tomorrow in class, or if you have one of these problems on an assessment, that's what I would kind of hope you would do. You would sub in a value for y and then test to see if this equals that is true. Now, once you're done, you always want to look and make sure whether or not this is further factorable. So if I do 4 times 9, that's 36. That's my AC value. My B value is 6. So then the question is, are there factors of 36 that add up to positive 6? And it doesn't seem like there is. So this is not further factorable. Okay. And so there's your final answer. Okay, I'll see y'all tomorrow. Tomorrow we'll practice all of the different methods of factoring.